Recently, I got to go hang out at the Idaho National Labs in Idaho Falls in Idaho. There are thousands of people at those labs working on the future of energy for the United States. They're working on renewable energy, of course. They're working on all kinds of things that I had no idea were happening around recycling and waste processing, but primarily they are working on nuclear reactors. It was such a treat for me to go see all the work they're doing. We have engineers who spent their entire careers working on the technologies for nuclear reactors that we need to make this happen at a large scale. I don't know why we haven't been putting these people to use and making a lot of nuclear reactors. They know everything. They're testing fuels, they're testing metals, they're testing different reactor designs, they're testing all this stuff. They have live reactors there since the 50s that they use for this kind of testing. It's incredible what I got to see. And one of the folks I got to meet there was Ahmad Al Rashdan. He's a PhD that's working as a senior research and development scientist in the Nuclear Science and Technology Directorate at Idaho National Labs. This is a short but important conversation for me. You get to see me asking the questions that I need to ratify my view and understanding of what's happening with nuclear reactors, what's possible with them. I'm getting to ask an expert who spends his entire career every day working on these technologies. And it's very important. I don't want to have the wrong ideas because you hear me evangelizing nuclear reactors a lot. I want to know as much as possible. And I have a chance to pick some brains now and then of people who are in different parts of the entire chain of making this possible.
I've never met anyone like it.
You could hack anybody's phone in a matter of minutes. Who is that guy? Who can do that?
Alice is the most interesting man in the world.
He's one of my favorite people on the planet. Inventor.
Wicked smart.
The master of cutting corners.
If you had a dead body in your trunk, who would you call?
He would get arrested immediately in a lineup.
I stood in line to get his autograph.
You know, his mouth can barely keep up to his brain.
I don't actually know what Pablos does.
A hacker magician.
Man of the future. Future.
So my name is Ahmad Al Rashdan. I'm currently leading multiple efforts as part of two Department of Energy programs. One is called the Lightwater Reactor Sustainability Program. LWRS is the abbreviation for that. The LWRS is a program that is aimed towards helping the current fleet become more economically competitive without impacting safety. So we look at various new ways to automate the processes that we have in the plant. And one of the challenges we have with the current industry is it's very labor intensive and very demanding in terms of manpower. And if we could find ways to introduce automation into the mix, we think we can reduce significantly the demand on manpower and with that reduce the cost of operating those reactors. Now that's one role. The second role I have is I'm also leading a pathway under another program called Advanced Sensors and Instrumentation program. It's another Department of Energy program. This program is focused more on sensors and means to use them for advanced reactors. And my specific focus is on autonomous operations of advanced reactors and means to enable that.
Can I ask you a couple questions about this? So going back to the Lightwater reactors, about how many of the U.S.'s civilian reactors are Lightwater reactors?
So all the operating power reactors are Lightwater reactors in the U.S.
Is it fair to characterize them as reactors that were designed, you'd say, maybe before we had access to the kinds of automation that we have now, the monitoring systems that we have with sensors and computers and all the things that you would use if you were designing something from scratch today?
Sure. So yes, the answer is yes. So most of our industry was built, the nuclear power industry in the US was built in the 60s and 70s. Yeah. And we had few reactors built in the 80s. And then there was a pause up till recently. We had two new reactors built. So the technology kind of froze, I would say, to some extent from that period onwards. There were some advancements, but things were really slow because the nuclear industry is very highly regulated and changing the way it's operating is not something you would just do on the fly like you would do with the fossil industry, for example. So it moved much slower than other industries.
Right.
And that's why we are now, back in 2008, 2009, the government realized that we need to help the industry move forward, and they launched this new program, the Lightwater Reactor Sustainability Program, to help the industry
And
explore those venues.
so when you say it's labor intensive, what are those people doing who are working at a reactor?
We have various organizations. We have operations, operators, whether they're in the control room or in the field. We have maintenance staff. We have engineering. We have procurement. We have security, which is one of the large forces in our large manpower demanding forces in the nuclear power plants. We have so many, and of course, administration and so on, so many different organizations with different roles. And even the work process in a nuclear power plant, for example, which we call the work management process, which is how you identify an issue or something that needs to be fixed in the plant and move it forward to where it's actually done. So many people are involved. Lots of time is being spent. And we're actually looking at that specifically at the moment to try to figure out where are areas of improvements, areas where we can use maybe AI or automation in some form and reduce the requirement on people doing those activities.
If you were designing a reactor from scratch today, what fraction of those people do you think you could get rid of?
That's an interesting question. So for advanced reactors, part of let me give you an example to give you the challenge, to explain to you the challenge. So currently we have, for example, 1,000 megawatt electric reactors, which is our current fleet. Typically they're at that power rating. And we have somewhere between 500 and 1,000 people running them. So think about that. Now we're going to drop down the power from 1,000 megawatt electric to maybe 20 megawatt electric, so 2% of the power. Can we drop the number of people operating that reactor to 2%? So going back down from 500, that's 10 people. Now, it's still a reactor. That 20 megawatt electric is still a reactor. It has the same, maybe not the same, but a close enough complexity, and it requires a lot of maintenance, operations, and so on. So now if we want to sustain the same economics of scale, we need to drop to 10 people. Whether that's achievable or not, that's what we're working on. We're trying to enable that. And that's where automation is going to come in. And we have to automate a lot of the activities that are a part of the current fleet now to make this possible with advanced reactors.
So if we made an advanced reactor that needed 2% of the people, and we automated everything so that 10 people could run it at 20 megawatts, could we then just grow it to 30 and 40 and 100 and 1,000? What do we need all those people for? If we're building an advanced reactor, things are automated, it can't melt down like a historical reactor design, things like that. Why can't we just automate 1,000 megawatt reactor?
We're working on that too. We're trying to get the 1,000
Why
megawatt.
would we make a 20 megawatt reactor?
Okay, so there are different applications that demand this type of reactor. That's an interesting question. So we realized recently that we have applications, for example, that are far from the grid, that would require some energy in some form, whether it's heat or electricity. There's also unconventional applications that would require some sort of heat. So there are
some, but to solve energy as a large-scale problem for humans, we just need a bunch of big reactors anyway.
Correct.
So making them small, does that have any other advantage other than sounding friendly?
They're also easier to deploy. Another advantage is you can manufacture them in a modular manner. So we can think about them like cars now. We can start building them in manufacturing facilities and just commission them and where do you need them. You don't have to spend 2-3 years or maybe even more. We took, I think for the last one, we took more than that, much more than that, to build a reactor. Now you have it built in the factory, shipped, and it's plug and play.
I love that vision, but why wouldn't we just build big reactors in a factory?
Oh, how are you going to move the reactors then from the factory to the actual setup? And also there are a lot of complications in terms of design of conventional reactors, the water-based ones. They're because of the physics, they do require much more space. And there are much more complications associated with these versus the smaller one, the micro reactors or the advanced reactors, we call them that too. They could be much more compact and they are safer. At least I would say most of them, the ones I'm familiar with. And one thing I want to add also is when we talk about automation as part of the enabling technologies to enable us to run those reactors with 10 people, for example. Another aspect we're looking at is having maybe centralized control rooms and service centers for multiple reactors. So we can, even those 10 people can be operating multiple units in one location and they would service those reactors as needed.
If I were starting today trying to build a gigawatt scale reactor, would I choose a light water reactor?
As of now? So in the US, it depends on your application, honestly. So if you're building a large baseload energy plant, you probably would go with a conventional reactor. However, we do have generations of light water reactors, and currently we are at generation 3 and we're looking even at generation 4. But if the application demands some form of special requirements that would fit more an advanced reactor or micro reactor, then you would go with that one for sure.
Is there what's an example of special requirements?
Just like I mentioned, the grid, for example, if you want to build something in a rural area in Alaska and you don't have or the fuel supply, sometimes you don't have that fuel available somewhere where you can build fossil-based, for example, plants and power it. Another example, as I was mentioning, is if you wanted something to be deployed really quickly. An example might be like a base that you're building for offshore for some reason. That's where that modular reactors would fit better than, for example, you spending the time years to build a reactor.
Yeah.
You would want something to be manufactured again in a factory and shipped.
I guess what I'm trying to get at is there a reason why, if I could build that gigawatt reactor for Alaska using advanced reactor technology, why wouldn't I just do that in every other context? What's the advantage of doing the light water reactor in any context?
So it's different. So light water reactors versus the advanced ones. Advanced ones are mostly with different types of fuel, different type of coolants, and different technology.
Yeah.
With the light water reactor, you again compromise on the size front.
Yeah.
Versus with the advanced ones, you can and of course, and as I mentioned, on the manufacturing front. The other thing is the fuel type itself is different, and the coolants are different. So to enable those features of advanced reactors, we would need to change the designs that we commercially use.
Yeah, for sure.
Cool. Am I answering your questions correctly?
No, this is great. Thank you. Yeah, it's super helpful. What's the most meaningful advancement? Like you said, a lot of these old reactors, the ones we have now, were designed in the 60s. We've been running them for a long time. In your career, you've been looking at ways of extending their life, improving them, making them safer, making them more automated, reducing the head count needed to manage them and maintain them. What's the biggest win we've had on that? What's the best advancement we've been able to apply to the older reactors so far?
So I think what we're doing now is going to be the biggest win, because again, the industry has been very labor intensive, and we're seeing a lot of success with the industry moving towards a different mindset where they think this now innovation is a key enabler of them becoming more economic and saving the industry. Yeah. We've witnessed a few plants shut down starting a decade ago, and now it's slowing down, which is a good sign.
Yeah, slowing down the shutting down of older reactors.
Correct.
Yeah. Do you feel like we're in a good position to be able to extend the life of some of these reactors and keep them going?
I think we are. Good. So they did initially, so the way the reactors are licensed, the current fleet reactors, they have 20 years license every time they get, and they renew them every 20 years.
Yeah.
And we have gone 60 years and we're going to 80.
Wow.
And they have been operating at a very high power capacity, meaning they're very efficient. We have very rare outages or shutdowns, which is something very indicative of how good the industry or in terms of performance is. For example, I worked in the fossil industry before I went to nuclear, and a shutdown of the power unit or the power plant is something you would expect every couple of months. Yeah. That doesn't happen in nuclear. It's much more efficient in terms of generating of power, much safer. It's very, very organized and a high performance industry, in my opinion.
Wow, super cool. And then the things you're working on, what are you most excited about that you're working on here? It seems like there's a lot of projects going on here that are really cool.
Yeah. So mostly, I know you've probably heard this before, but AI. So I would say almost every project I'm working on has some AI element.
Yeah. What's an example of how you're applying AI?
I've been applying AI on time series data, like sensors data for diagnostics and prognostics of equipment.
Yeah.
We're looking at AI now to inform control for autonomous reactors. I've been working also on AI to analyze text in work management documents in nuclear power plants to make decisions for the human and inform the human what they need to do. We've been working also on the computer vision side. We're using AI to detect anomalies and rust and corrosion, detect fires. I can keep going. We have so many applications.
And when do you think you started describing what you're doing as using AI? Has it just been the last year or two?
As part of the Lightwater Reactor Sustainability Program, I remember back in 2016 where I wanted to start using AI for anomaly detection and for equipment monitoring.
Yeah.
And that was the first time I think I was pushing for that with the program, and the program, fortunately, was very recipient of that. They supported it, and we started working on it back then.
Yeah.
When it wasn't as a buzz of a topic as it is
for
now.
sure.
But I think we were seeing a vision that this is going to happen.
Yeah.
AI can provide us with much more insight than what we do with, for example, statistical methods. And so that was the first project I was involved in 2016, 2017. And then it grew rapidly. And as I said, now everything I'm working on is AI.
Yeah, good. Yeah, deep learning sucks at time series data, so we must be taking some other approach, hopefully, for doing the time series data.
Yeah, so we look at what the literature. So a key aspect of what we do is we try to not reinvent the wheel as much as we can.
Yeah, good.
Of course, keeping track with everything that's going on is really challenging, but we tried our best. We go to conferences, professional ones that are looking into certain specific topics that we're targeting. And then we focus on the applied side. So we try to figure out how do we leverage, for example, what the big tech companies are doing when they create, for example, a large language model. How would we benefit from this the best, rather than trying to create our own language model? We try to refine it or modify it for the purposes we're looking at. And we do the same with all users of AI, at least in what I'm doing. We don't fundamentally change the science. We leverage the science and we advance it as much as we can.
Yeah, great. You've been working on nuclear reactors for a while now. What bothers you the most about on your friends and family and what people think of nuclear reactors? Maybe it's less of a problem in this neighborhood, but what do you wish people knew? Actually,
today I saw an article on nuclear, and it was on things. I don't remember the exact title of the article, and maybe I don't want to mention it specifically, but it was on things you should know about nuclear.
Okay.
And I would say more than half of them were false statements, in my opinion.
Oh, okay.
About nuclear waste, for example.
Sure.
We have waste, as you probably know, nuclear waste can be used as fuel.
Yeah.
And nuclear waste can be reprocessed. It can be reduced significantly. And even if you store, I think the waste we generate across the whole U.S. in a certain physical location, it's going to be insignificant compared to what the, for example, CO2 impact is.
Yes.
That's an example. And there were a few of these where I'm reading and I'm like, this person is writing about AI, about nuclear, and doesn't know what a nuclear is.
I know, it's tough. Yeah, it's exciting though, because a lot of these stories are just so far off the rails that if you show people what's really going on, it's so much better than they imagine.
Yeah.
And
that's why I moved from fossil to nuclear.
Yeah.
Because I worked for the fossil industry for a while.
Yeah.
And then I realized this is not the solution. We need to think smarter.
Yeah, we want that to be a smaller part of the solution.